Alright, so this is going to be going over this worksheet just in case you struggle with it, which it shouldn't really be that hard because we've spent the last couple days doing this stuff. Alright, it's just now it's mixed together. Because on the test, I'm not going to always say, hey, this is an ionic bond or this is a covalent bond. What's that? Because you should know by now that you write the formulas very different based on, or the name of the compound is very different based on the whether it's an ionic bond or a covalent bond. Alright, so it tells you up at the top, I'm not going to read it all, but it tells you what to do if it's an ionic bond. If it's, because ionic bonds occur, you should know, because you have to know this. Alright, if you didn't watch the notes, you're going to have a hard time with it. You have to know that an ionic bond, and this is where it's important to know, that it's between a metal and a non-metal. Alright, so it's between, a metal and a non-metal. And if you look at the periodic table, you can see all of our metals are, let me just slide over here, with the exception of like hydrogen, which belongs over there as a non-metal. Alright, and it doesn't belong over there, but yeah, I just mean in terms of a non-metal. These are all metals. You have alkali earth metals, your transition metals, and then you start getting into like the poor metals, the the poor metals. You have semiconductors, etc. But so those are basically all our metals, and then our non-metals are the green and the purple. All right. So here's our non-metals. So basically, my kind of rule of thumb, and I'm pretty sure I've talked about this, is if you jump across the periodic table, because most of the time I'm not going to ask you about these elements over here, these metals. So if you're going across the periodic table, it's an ionic bond. Alright, so right off the bat, that should tip you. Hey, it's an ionic bond. If it is on the same side of the periodic table, alright, over here, then it's going to be a covalent bond. The only exception to that, obviously, is hydrogen. Alright, so the first thing I say that you have to do when you figure this out, because covalent bond is two nonmetals bonding together. Alright, and you write that differently because you're going to use the Greek prefixes as opposed to the crisscross method, which we've worked on. Alright, so the first thing you need to do, identify the type of elements. Well, where are they located on the periodic table? So like here I have magnesium. Magnesium is right here. Alright, it's on the left. So right away I know two metals aren't going to bond. So since magnesium's on the left, chlorine's on the right, I'm going across the periodic table. I know that I have a metal and a non-metal. So I have an ionic bond. Alright. I don't know what just happened there. Alright, so I have an ionic bond. So now, when I name the compound, I don't use, alright, and I think I put that up here, I do not use the Greek prefixes. Alright, that's for covalent bond. Do not use Greek prefixes. Alright, because that is always going to be the formula for when magnesium and chlorine bond. Alright, so when you write an ionic bond, it would just be simply magnesium chloride. You don't put dichloride because, remember, there's a transfer of electrons that are occurring with an ionic bond. So since electrons are being transferred, there's magnesium only has two to give up. Chlorine can only take in one. So when magnesium and chlorine bond, that is always the formula. It's not like a covalent bond where they can share multiple pairs of electrons. Since there's a transfer that's occurring, magnesium always has two to give up. Chlorine only can take in one, so it would always take two chlorine to bond with one magnesium. Alright, and remember to add that IDE to the end. Alright, so the first step you want to do is just identify the type of bond. So here we have carbon. So now we have carbon right there and bromine right there. Alright, so they're on the same side of the periodic table. So since they're on the same side of the periodic table, it is a covalent bond. I have two nonmetals. Covalent bond. Alright, so that's the first thing you need to do. Identify the type of elements. If they're on opposite sides, it's ionic. Same side, covalent. Alright, so covalent. Alright, so now, since I'm using a covalent bond, that's where I got to use those Greek prefixes. Alright, so that's where I'm going to use the Greek prefixes. So I have carbon, one carbon. Remember, you don't have to write this for one carbon, but I have carbon. You don't have to write mono if it's the first one. Carbon, and now I have 4 bromine, so it'd be tetra. Tetra is 4. Alright, and then it'd be carbon tetra bromide. Remember, you still add the IDE at the end to signify that it's part of a compound. Alright. Okay, well now you say, well, what about it? What if I'm given the name? Alright, what if I'm given the name? Well, same thing, I still gotta look. Is it ionic or covalent? Well, the name should tip you off because you can see what's absent here. Alright, so since there's an absence of Greek prefixes, you should know right off the bat that it's going to be ionic. But even if not, you know, if you're like, well, I'm going to still find them. Well, lithium is over here. Nitrogen is over here. Alright, so now you have to remember, ionic, I'm using the crisscross method since there's a transfer of electrons. The name itself won't tell me how many atoms are in the formula, so I can't just write LIN, alright, because nitrogen, just to recap this, lithium is in group 1, so it's got 1 in its outer shell. Remember, now we got to use the oxidation number. How many does it need in order to be a full outer shell? Nitrogen is right here, so I'm going to put my finger on nitrogen, and I'm going to count to the nearest noble gas. 1, 2, 3. Now it's 3 spaces away, so it's got to gain 3. Remember, it's got 5 in its outer shell, but that's not how many we write. It's got 5 because I know that because it's in group 15. Remember, we do 1, 2, skip the dip, 3, 4, 5, 6, 7, 8, except stupid helium. So now we have nitrogen here, and it's not how many it has, it's how many it needs in order to be full. Alright, so it's 3 spaces away from the nearest noble gas. Alright, so this should all just be a recap. Alright, so for when I write the formula then, since it's not given to me in the name, I would write lithium plus 1 because it has 1 to give up. Nitrogen has to gain 3 negative charges, 3 electrons in order to be full. Now I do the crisscross. It would take 3 lithium, because since lithium only has 1 to give up, but nitrogen needs 3, it would take 3 lithium to bond with 1 nitrogen. Alright, that's my formula. Alright, now I'll do one more, just for the sake of kind of making this a little bit quicker. Now if I'm given a name, once again, now here we have another situation where I'm given a name. Now you see a Greek prefix, dioxide. Right away, that should tip you, oh, it's covalent. I know it's covalent because you do not use Greek prefixes when you are writing an ionic bond. Right? You only use Greek prefixes when you write a covalent bond. Alright, and these are super easy. So if you're given the name of a compound, it's super easy to write these. Nitrogen dioxide. What tells you right there? All I gotta know is my Greek prefixes. Alright, so if I know di is 2, alright, there's nothing in front of nitrogen, so therefore I know it's 1. So nitrogen dioxide, NO2. That's it. Alright, di is 2, there's 2 oxygen. You don't crisscross, you don't do any of that stuff, so it just tells you right in the name how many there are. Alright, so if you don't have a Greek prefix in the name, so if you're given a name, like right off the bat, just looking at these, these right here, no Greek prefixes, I know they're ionic. I know I'm doing the crisscross method then. Alright, if they had a Greek prefix, I know it's covalent, and I just write however many it has right there. Alright, so it's one of those things where you just got to know, ask yourself what elements are involved. Are they metal, non-metal? If they're non-metal, I'm using the Greek prefix. If they're 2 non-metals, if it's metal, non-metal, I'm using the crisscross method. Alright, so not overly difficult. Remember, you never use Greek prefixes when you deal with ionic. It's only covalent. So that's all really the whole thing is. It's just a hodgepodge of doing them different. I'm not going to go through the whole thing with you, but that's basically all it is. You just have to ask yourself, what are the elements involved? If it's metal, non-metal, it's ionic. If it's 2 non-metals, it's covalent. And then use this information up here. If it's ionic, use oxidation numbers, not Greek prefix. If it's covalent, don't use oxidation numbers. Use the Greek prefix. Pretty simple stuff.